Hi friends, today I am here dealing with the topic polymers. Now we all are familiar with the term polymers, isn't it? In our day-to-day life we use many items made up of polymers. For example, plastic is a type of polymer. Now today what I have to cover mainly is what a polymer is, what are the terms related with polymers and classification of polymers. Now first one, what is a polymer? From the word polymer itself we can understand that this word is made up of two words, that is poly, which means many, and mer, which means units. That is, many units combined together to form a larger unit or a larger molecule of high molecular mass called a polymer. And these basic units are called monomers. I can show an example. CH2 double bond CH2. This is ethene. You represent ethene as CH2 double bond CH2 and the bond present in between is covalent bond. Once ethene undergoes polymerization, this bond breaks and one valency goes to this carbon atom, another valency goes to this carbon atom. So when you write ethene as NCH2 double bond CH2, it polymerizes to give CH2 single bond CH2 N times. That is, N-ethene polymerizes to give a polymer with N times. That is, ethene is a monomer of, this is polythene. Ethene is the monomer of polythene. So you get a polymer from ethene. The process of formation of a polymer from a monomer is called polymerization. Now moving on to the classification of polymers. Next is classification. Classification of polymers is based on four types. First one is based on origin. Second one is based on structure. Third one is based on mode of polymerization. And fourth one based on molecular forces. Now based on origin, polymers are classified into three types. They are natural polymers, synthetic polymers and semi-synthetic polymers. From the word natural itself we can understand that the polymer it will be obtained from nature. The polymer that you get from nature is known as natural polymer. For example, starch, proteins, glucose, etc. Now synthetic polymers. Polymers which are man-made or artificial. Artificial polymers are called synthetic polymers. For example, nylons. Nylons are an example for synthetic polymers. Now semi-synthetic polymers. Semi-synthetic polymers are also natural polymer but which undergo certain chemical modification so that their properties are exhibited properly. So they are also natural polymers which undergo certain chemical modifications. For example, cellulose acetate. Now these are the classification based on origin. Based on origin it is classified into natural, synthetic and semi-synthetic. Now based on structure, polymers are classified into three types. Based on structure, they are classified into three types. First one is linear polymers. Now linear polymers. The monomeric chains, they join together to form a long chain, a long straight chain. They join together to form a long straight chain, and such polymers are called linear polymers. And because of they are closely packed, because of their close packing, they have high density, high melting point, and high tensile strength. That is, monomeric chains, long chains are formed. They link together to form long straight chains. And they have close packing, and due to their close packing, they have high molecular melting point, high density, and high tensile strength. Now, example for linear polymers are polyethylenes. Now, next is branched chain polymers. Branched chain polymers, in branched chain polymers, monomers link together to form a long straight chains but with few branches. Long straight chains are formed with branches. They are irregularly packed. And because of their irregular packing, they have low density, low melting point, and low tensile strength. Example, nylons. Now third one is based on structure. Third classification is cross-linking polymers. In cross-linking polymers, monomers are linked together in such a way that a 3D structure is formed. A 3D structure is formed in cross-linking polymers. There will be large number of cross-linkings between the chains. Example, bakelite. Now these are the classification based on structure: linear polymers, branched chain polymers, and cross-link polymers. Linear polymers are long straight chains and close packings, and they have high melting points, high density, high tensile strength. Whereas branched chain polymers, they are long chains with branches, they are irregularly packed, they have low density, low melting point, and low tensile strength. Example, nylons. And cross-linking polymers, they are the polymers in which monomers link together to form 3D structure, and they have large number of cross-linkings. Example, bakelite. Now next mode of classification is based on polymerization. Based on polymerization, mode of polymerization, polymers are classified into two types. Based on mode of polymerization, they are classified into two types. They are addition polymers and condensation polymers. Now addition polymers. Addition polymers means, for example, I can show it with the same example which I took earlier. Ethene, CH2, double bond CH2. When it undergoes polymerization, this bond breaks. As I told before, this bond breaks and this ethene gets one valency here and this carbon gets one valency here. So when you add another ethene with this, they add up and you get polythene. So if you add one more monomer, it joins at the end of this earlier formed polymer. So the chain continues. If you add another monomer, it also joins at the end of earlier formed polymer. That is what is called addition polymerization. The chain rapidly, it continues growing. So addition polymerization has two categories. They are homopolymers and copolymers. Homopolymers and copolymers. Homo, as the name indicates, homo means same. Same types of monomers combine together to form a polymer which is known as homopolymers. That is here. This is a monomer, that is ethene. This is also ethene. So same monomers combine together to form polymer. Now next is copolymers. Two or more monomers combine together to form a polymer. Example, Buna-S. Buna-S is also known as styrene butadiene. The polymer is called styrene butadiene and the monomers of styrene butadiene are butadiene and styrene. That is NCH2 double bond CH, single bond CH, double bond CH2. This is called butadiene. Butadiene along with styrene X, C6H5. Now this is styrene X, C6H5, single bond CH, double bond CH2. When butadiene is added with styrene, you get styrene butadiene. CH2, single bond CH, double bond CH, single bond CH2. N times CH2, single bond CH, C6H5, X times. That is, butadiene and styrene are different types of monomers. So two monomers combine together to give a polymer. That's an example for copolymers. Now, second type of polymers based on mode of polymerization is condensation polymers. Now, condensation polymers are the polymers which are formed when they are linked together. You get a polymer with the elimination of small molecules such as water, ammonia, etc. That is, monomers linked together to give a polymer with elimination of small molecules such as water, ammonia, etc. Example, nylon 6,6. Nylon 6,6 is formed from the monomers hexamethylene and adipic acid. Hexamethylene diamine and adipic acid. This is hexamethylene diamine. Hexamethylene diamine along with adipic acid you get nylon 66. NH, CH2 6 times NH, CO, CH2 4 times CO, N times plus NH2. That is hexamethylene diamine and adipic acid polymerizes to give nylon 66. Along with water molecule. This is an example for condensation polymerization. Here two monomers are linked together to form a polymer along with elimination of a molecule of water. Next is classification based on molecular forces. Polymers are classified into 4 types based on molecular forces. First one is elastomers. Second one is fibers. Third one is thermoplastics. And fourth one, thermosetting plastics. First one is elastomers, second one fibers, third one thermoplastics, and fourth one thermosetting plastics. Now elastomers. In elastomers, there are weak intermolecular forces between the polymeric chains. They have high degree of elasticity. They are rough, tough, and stretchable. And they regain their original position when the stretching force is removed. For example, natural rubber. Natural rubber is an example for elastomers. That is, weak intermolecular forces are present between the polymeric chains and there is high degree of elasticity. Elastomers are rough, tough, and stretchable. Example, rubbers, and they regain their original position even after removal of stretching force. Now second one is fibers. Fibers have strong intermolecular forces between the polymeric chains. They have strong intermolecular forces between the polymeric chains and they have high tensile strength. They have high tensile strength and fibers can be woven into fabrics. They can be woven into fabrics and they are stiff and tough and they are abrasion resistant. Example, nylons. Fibers, they have strong intermolecular forces present. There are strong intermolecular forces between the polymeric chains. They have high tensile strength, and examples are nylons. They can be woven into fabrics. Now, third one is thermoplastics. Thermoplastics are those polymers where the intermolecular forces are present between elastomers and fibers. And such polymers, they soften on heating. They soften on heating and hardens on cooling. They soften on heating and hardens on cooling. Example of thermoplastics are polythenes. Examples of thermoplastics are polythenes. Now, fourth one is thermosetting plastics. Thermosetting plastics are those polymers, thermosetting polymers. Thermosetting polymers are those polymers which undergoes permanent change on heating. They undergoes permanent change. Such polymers undergoes permanent change on heating, and they are hard, as well as infusible. For example, bakelite. Now, based on molecular forces, polymers are classified into four types: elastomers, fibers, thermoplastics, thermosetting polymers. Elastomers, they have weak intermolecular forces of attraction between the polymeric chains and high degree of elasticity. They are rough, tough, stretchable, and they regain their original position even after the removal of stretching force. Example, rubber. Second one is fibers. They have strong intermolecular force of attraction between the polymeric chains. They have high tensile strength. They can be woven into fabrics. They are stiff, tough, and abrasion resistant. Example, nylons. Third one is thermoplastics. They are the polymers whose intermolecular forces are between elastomers and fibers, and they softens on heating and hardens on cooling. Example, polythenes. Fourth one is thermosetting polymers. These are those polymers which undergoes permanent change while heating, and they are hard, infusible. Example, bakelite. Next one is vulcanization of rubbers. Vulcanization of rubbers, it means it's a chemical process. It's a chemical process done to improve the physical properties of rubbers, and natural rubbers and synthetic rubbers. It's a chemical process which is done to improve the physical properties of natural as well as synthetic rubbers. Natural and synthetic rubbers are very soft and sticky, and they are low resistant to friction. So articles made from such rubbers will not last so long. So they are hardened, so they can be used further. So in order to harden them, they are heated with sulfur. The process of introducing crosslinks between the polymeric chains are known as vulcanization. Process of introducing crosslinks between polymeric chains is what is known as vulcanization. Now vulcanization of rubbers. In the case of rubbers, vulcanizing agent is sulfur. So sulfur is used as vulcanizing agent in rubbers. So today we studied about polymers. What is polymer? Terms related with polymers and classification of polymers. Polymer, as I told earlier, it's monomers linked together to form polymers, and the classifications are based on origin, structure, mode of polymerization and molecular forces. Based on origin, they are classified into 3 types: natural, synthetic and semi-synthetic. Based on structure, also 3 types. They are linear, branch and cross-linked polymers. Now based on mode of polymerization, they are classified into 2 types: addition polymerization and condensation polymerization. In addition polymerization, there are 2 categories. They are homopolymers and copolymers. Now the 4th one is based on molecular forces. Based on molecular forces, they are classified into 4 types: elastomers, fibers, thermoplastics and thermosetting plastics. I hope this session is clear for all of you. Thank you.